Good evening, I'm Gio Almonte and today we'll be discussing Chapter 26 of our presentation in Physics 2. For our first question, we have a question. A resistor with R1 is equal to 30 ohms is connected to a battery that has a negligible internal resistance and electrical energy is dissipated by R1 at the rate of 34 watts. If a second resistor with R2 is equal to 18 ohms is connected in series with R1, what is the total at which electrical energy is dissipated by the two resistors? Well, first, we know that the formula for power is P is equal to V squared over R. First, we need to find the overall voltage. And from this, we can just derive by multiplying P1 by R1 and square rooting the full thing to create a final equation of V is equal to square root of P1 R1. After this, we just input our numbers, so square root of 34 watts multiplied to 30 ohms, and we have a voltage of 31.94 volts. Next, since we just added this into the circuit, we can infer that this is actually a series circuit. So, resistance in a series circuit is just a summation of the individual resistances. And looking back to our previous formula, since we're still trying to find electrical energy, we can use our old equation again of P is equal to V squared over R, where R is equal to R1 plus R2, given that there are now two resistances in the circuit. So we can input our numbers, so P is equal to 31.94 squared over 30 ohms plus 18 ohms or 48 ohms, and we end up with the final answer of 21.25 watts. For our next question, we have a question. In this figure, R1 is equal to 6 ohms, R2 is equal to 6 ohms, and R3 is equal to 7 ohms. The battery has a negligible internal resistance. The current I2 through R2 is equal to 4 ampere. What is the currents I1 and I3, and what is the EMF of the battery? Well, first let us get the equation I1 is equal to V2 over R1. This is because we already know what V2 is. And given the fact that R1 and R2 are in a parallel circuit, V1 and V2 is the same, so we can replace the V1 with V2. Next, we can have V2 is equal to I2 R2. This is just derived from the regular V is equal to IR equation. Next, we can substitute V2's I equal to I1 I2 R2 into the numerator of the first equation that we have. So now we have a third equation where I1 is equal to I2 R2 over R1. Next, all we need to do is to input our numbers. So we'll have 6 ohms times 4 amperes over 6 ohms, and we have an I1 of 4 amperes. Next, we know that the combination of I1 and 2 is in series with R3. And given that they are in series, we know that I is equal. So, all we need to do is to first add I1 and I2, which is 4 plus 4 and 8 equal to 8. And given the fact that the I of I1 and 2 is equal to the I of 8, we can infer that I3 is equal to 8. Next, we know that the EMF is equal to I times the total equivalent resistance. First, let us solve for the resistance of R12. Given that this is parallel, we can use the formula of R1 R2 divided by R1 plus R2. This is just 6 ohms times 6 ohms over 12 ohms, which gives us a total resistance of R12 of 3 ohms. Next, given that we now have a series type of circuit, we know that the equivalent R is equal to R12 plus R3, or 3 ohms plus 7 ohms is equal to 10 ohms. Finally, all we need to do is to input our numbers into our EMF equation. So our EMF is I times R equivalent, or 8 ampere, which we got at the letter A, multiplied by 10 ohms. And we have a final answer of 80 volts. For our final question, we have a question. In the circuit shown in this figure, the voltage across the 2 ohm resistor is 12 volts. What are the EMF of the battery and the current through the 6 ohm resistor? Well, first, let us first solve the current in this area. Well, all we need to do is to look into our figure, and we know that the current of I12 is equal to I2 and which is equal to I1, given the fact that they're in a series type of circuit. And based on our formula V is equal to IR, we know that I is equal to V over R. So I1 can be equal to V2 over R2, which is 12 volts over 2 ohms, and we get 6 ampere. Next, let us remember the concept that V12 is equal to V3 is equal to V123. This is because that V12 and V3 is in a parallel circuit, meaning that the voltage is always the same. Next, let us input this into our EMF. As we know, EMF again is our I times our total resistance. So all we need to do is to multiply our I12, which we've gotten a while ago, by the total resistance, which is just through adding our previous resistances. So we have 6 ampere multiplied to 1 ohm plus 2 ohms. Next, we get 6 times 3, which is equal to 18 volts. Finally, to find the current through the 6 ohm resistor, we just need to use our formulas. V is equal to IR, so we have I is equal to V over R, where I3 is equal to 18 volts, which is what we got a while ago from the EMF, which is also called voltage, and divided by 6 ohms, which is the given resistance in the resistor 3, and we have a final current of 3 amperes. Thank you for listening to me in this new problem solving for this chapter, and I hope to see you again in our next chapters.